Hello and welcome to a new webinar in Project FOReSiGHT. I'm Roxana Voicudorobanță. I'm project manager for this project that's been financed through the strategic partnerships in Erasmus+. This time I'm camera off because technology is the topic of our project, but however, sometimes it's not our friend. um and hopefully it will be a little bit more friendlier. However, this technology has facilitated today to have a guest from the other part of the world. um Before introducing Abhi and Dr. Abhishek Srivastava, sorry Abhi. I will let you know a little bit about Project FOReSiGHT. So it is a project that lasted for 30 months. It will wrap up at the end of May 2023. If you're watching this at any other point in time after this moment in which it is live streamed, we can let you know that Project FOReSiGHT is building upon the platform of the Block project that was focusing on the blockchain, and it develops the block projects into developing more knowledge, this time not just about the blockchain but about digital transformation, intelligent automation, artificial intelligence, algorithmic governance, and all that with a flavor of foresight, because things are moving so fast. We have to think in the future and think about the next elements with the future in mind. So that's it about Project FOReSiGHT. You can learn more about the project on our website and also on the blogs platform. I will give the floor to Abhi. Thank you so much for joining us and providing your technical expertise. I will give the floor to you and ask you to give us, in the beginning, a little bit more information about your background. So, where do you come in this story, in which you are a guest this time?
Mhm.
So, thank you so much for joining. Please.
Okay. Thank you, Roxana. And hello, everyone. My name is Abhishek Srivastava. And in short, people call me Abhi. Like most of the Indians of my generation, I started as a software engineer. I was lucky enough to work at some of the leading tech companies like Verizon. I was for many years at Adobe Systems, where I was part of Acrobat PDF Maker team. So every time you are using a PDF file, I hope it works fine. And if it's working fine, at least some little bit of, like contribution was of mine. Then after that, I went for my PhD in a business school, which was a very interdisciplinary experience. I involved concepts from psychology, management, marketing, and of course, computer science in the area of recommender systems, which we will be focusing today. And after my PhD, I was in the industry for some time. I was involved as a consultant to some big companies and also to startups. And then I moved to academia around 3 years ago. And right now, I am an assistant professor at a Indian Institute of National Importance, known as Indian Institute of Management, Visakhapatnam. And over here, I teach MBA students. So this was a quick brief about me. And moving forward, as you can see on the screen, the topic for today's presentation or discussion is personalization in the era of artificial intelligence. And before I move to this topic, I'll start with very small old story from the times of Buddha. It was mentioned in a text around 2005 year 2500 years ago, old text, and it talked about few blind men who were trying to describe an elephant. So what happened was the person who was touching the tusk of the elephant, he described that elephant to be like a spear. The person who was touching the tail described the elephant like a rope. The person who was touching the trunk described it as a snake. The person who was touching the elephant's leg was describing it like a pillar, all the blind men touching the same object but were describing it in different ways. Somehow I feel something similar is happening or happens all over the world when we talk about artificial intelligence. Of course, a lot of startups and new companies, they are claiming it to be like a snake oil, something that will solve everything. People from different disciplines, different domains, different expertise, they describe it differently. For example, people from legal background or sociology background, they might focus it from the privacy concept. People from business domain, they'll think it about automation, making money. People from computer science background, they will think it's all about algorithm, databases. People from stats and mathematics background, they will describe it from machine learning perspective, and so on. So, going forward, in this talk, we will be talking about personalization in the era of AI, and we will be looking it from the perspective of Rexis, that is recommender system. Okay, now I have a question for all of you. Personalization is a central tenet of modern e-commerce online experience. Do all of you agree with it or disagree with it? If I ask this question in general in my class, almost everyone agrees with it. Dr.
Yes,
Roxana?
because we want ads that are based on our needs and based on what we want, and we like being in the bubble, in
Exactly.
our
So
own
true.
bubble.
Exactly.
But it increases the feeling, which is strange to some extent. It increases the feeling of being seen as a customer. um,
Exactly.
so we want personalized thing and individualized thing because of this, because we feel seen as a customer, even if we are rationally aware that it's fake.
In indeed. 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 Of course, today's modern customer, like he or she, is bombarded with information overload. So in some ways, we can also look Rexis from the perspective of an information filtering mechanism. So moving forward, this personalization, which you see in online experiences, is basically achieved via something called recommender systems. And here is a meme which shows recommender system is almost everywhere. Once you become conscious about it, once you start seeing it, you will find it that it is present everywhere. You'll find it in Netflix recommendation, Tinder matches, job recommendation, news recommendation, almost everywhere. Hotel recommendation, electronic item recommendation, everywhere. So once you start seeing them, you will find them everywhere. Now, in fact, in our community, in Rexis community, we often have a joke that everything has become a recommendation. The chances are that if you are seeing this webinar live, you might have got its notification through some notification that might have, been personalized and recommended for you. So, some of the key takeaways that I want you to take away from this session would be: first, what is recommender system? Second, how do they fundamentally work to achieve this personalization or personalized user's experience? And third, and most important, why it is no longer just a computer science concept, and why it is important for you and everyone in our society to know about it. I hope by the end of this presentation, this session, all of you will have answered to these three key questions. So, recommender systems. If I have to define it, of course, there are multiple definitions. One of the most agreed upon definition is basically it refers to family of algorithms. It's not a single algorithm. It refers to family of algorithm that predicts the level of preference of a given item by a user and are used to provide a list of recommended item a user might be interested in. Don't worry if it looks a bit complex, we will break it through and we will see different element of it. And predominantly it was deployed by e-commerce system to increase customer loyalty. As Dr. Roxana was talking earlier, customers feel seen, so increases customer loyalty. It helps in cross-selling and upselling of product. Some of the aspect of recommender system that we'll be talking about will be its origin, approaches, various approaches. Then we'll talk about the idea of transfer learning. Then we'll talk about context-aware recommender system, cross-domain. We'll talk about some special kind of users and user modeling. First, let's talk about this level of preference, because basically that is one of the most important part of any Rexis system. Now, preferences, either they can be explicit in nature or implicit. I'm sure all of you would have some experience with purchasing products on the likes of Amazon and all, which have 3-star or 4-star or 5-star ratings for a product. So 1 to 5 star rating system. Then you have thumbs up, thumbs down. In YouTube, you would have seen. Some places you'll have like Facebook like, or some places also dislike. In such scenario, a user, after consuming a content or a product, gives their feedback explicitly. So it is very direct in nature. However, there can be also implicit feedback. In this case, a user preference is not collected directly, but indirectly by observing their behavior. Companies or the system developers can know what is user's preference for that product or that content. So how it can be achieved? Via observing purchase history, browsing history, search pattern, content consumption history, and so on. So this was about preference. Dr. Rox, any questions so far
I
on
was just
preference?
thinking. I was just thinking and looking while you were talking, um, at the Spotify recommendation algorithm, which actually has a little bit of both. I mean, it carries the explicit feedback in which you hit love the heart, the green heart next to the song, and that will add it in your playlist and so on. But it also
Mhm.
has implicit feedback given through the styles that you want to choose, and so on and so forth. And the question is, um what sort of information, apart from these, the purchase history, the browsing history, and so on, would be considered too intrusive by the user, uh and also, which sort of information can we change? Let me switch from Spotify, which might not be used by all of our audience, to YouTube, which is a little bit more familiar. We are streamed on YouTube now, and on
Okay.
YouTube, at some point, you might find yourself in a playlist that does not reflect your necessary interest, but that you just clicked on, and
Okay.
that affects the algorithm, right? You clicked on that particular thing, it affects the algorithm, and then you get recommendations on that specific type of content, even if it might not be your average content to speak. So the question was, can I go back, so to speak, as a user? Can I go back as a user and say, this is not part of my usual of my usual content that I mean, alter, to speak a little bit in your terms, alter the implicit feedback with explicit feedback?
Okay. Okay. So very good question, and in fact, it has some different element. One thing which I think many of the audience might not be aware of. Sometimes, if you are seeing certain content which is being recommended to you, which you think or you are finding very odd, you think that it might be algorithmic failure, or why it is
Exactly.
giving me so big. Sometimes it might be by design. And in fact, by the time we have moved to the end of this presentation, we will talk about it. Sometimes they might deliberately want to, to show you some content which they know, or which they might be guessing that you might not even like, but still that might be pushed. So we will be talking about that is one of the way we can, when we talk about responsible AI or responsible recommender systems and all, when we
Mm-hmm.
want to break that filter bubble. So deliberately we might be showing you that content
Oh,
first.
okay.
And
Cool.
yeah,
So I
and
was
second,
anticipating a little bit.
yeah, and second thing was like you have an option where you can delete your search history and the information that Google knows about you. And once you delete that, of course, all this implicit feedback data that has been collected, it will be wiped off, and it will again be a clean slate. Those kind of things. So that can be one thing.
Uh, True,
Hmm.
agreed. But when you delete your entire Google history, you delete your entire Google history. The question was, can I not delete everything because I might
Hmm.
be interested in some things to still be there, but
Hmm.
delete a little bit,
So,
change a little bit.
so
But we'll
okay.
talk later about this.
No, no, it's a very interesting thing. So, of course, when you delete history, also you can delete specifically not entire Google history, but only your watch history for past 2 days or past 1 week or past particular whatever time frame. Only for
Hmm.
YouTube that can be deleted. And one more interesting thought is coming to my mind when I'm reflecting upon this question. On Facebook, what I did few years ago was just to beat its algorithm during my PhD days and all. I deliberately unfollowed a lot of my friends, especially
Oh.
those friends who were conscious or who were repeatedly coming in my timeline. I deliberately unfollowed, or Facebook gave that option not to receive content from not from that particular person
Hmm.
on your
Hmm.
timeline. So that was an experiment I did, and again, the kind of content Facebook started to show then was really bizarre. And then I realized maybe sometimes it's better to let algorithm decide what you like.
True,
So,
true.
and
But I was thinking, there's a meme on Facebook that says something like, uh, yes, Facebook, you don't need to recommend that person. I know as a friend, I know that person. I do not like them. I do not want to add them.
indeed, indeed, yeah.
Okay,
So,
moving
and
on.
we will come back to this again during the end part of the session.
Sure.
So, this was about preference. Now, we'll talk about the origin of it. And I think Professor Roxana, you and me both, at least we have lived long enough to have realized that a lot of really cool things, very, very interesting thing in computer science have some kind of, its root at this laboratory, this Xerox Park, Xerox Palo Alto Research Center. In fact,
Mm-hmm.
my organization, Adobe, so our founders, they themselves used to work at Xerox. They worked on the PostScript based on which the entire Adobe company was formed. A lot of graphical user interface concept Steve Jobs borrowed when he was visiting Xerox. A lot many things have come from their lab. So Xerox, I always think about a company which was really quite successful at a previous time, but somehow they were unable to capitalize on a lot of cool things they were doing, and other players kind of built an entire empire on that. So for recommender system, also one of the earliest and very classical work known as user collaborative filtering, using collaborative filtering to weave information tapestry. That is somewhere around 1992. This work was done over there. At that time, electronic mail was a new concept. In fact, it was not called as email. They uh, called it electronic mail. So, and which again was a big information load for all the scientists over there. So they solved that problem of information overloading on email system, and that kind of gave birth to modern collaborative filtering based recommender system. Well, let's move forward. Okay. Another seminal event happened in the year 2006. The very famous Netflix prize was launched. Basically, what it said was at that time, Netflix used a algorithm known as Cinematch. And the terms and conditions of the prize was that person or team which could reduce RMSE of that algorithm. RMSE is your typical root mean square error, a way to measure accuracy. If a person or team could reduce that by 10%, they will be offered $1 million prize. And this again, I look at as a seminal event, not only in the field of recommender system, but entire AI. I mean, remember, this is 2006, before we had Kaggle and all those competitions, etc. Followed and inspired by this, even other domains, other companies also launched their own competitions. And it is due to such these open competitions, a lot of development has happened. We talk about CNN and RNN and all those things. They are based on something called AlexNet, again a deep learning framework, which again was part of a different competition, not Rex's competition, but a different competition. So this Netflix prize 2006 was yet another seminal moment in the history of recommender system. In fact, this tradition has somehow continued. Every year we still have a something called Rex's challenge. Last year, a UK company in fashion domain, Dressipy, they sponsored this, and it was held at Seattle. I was lucky enough to be part of the organizing committee. And every year, this challenge is still, continuing and moving the field forward. Now let's move ahead.
I'm
Yeah.
gonna jump in just to add to the story of Netflix. And while you were talking, I was looking at um how many users, because the question in my mind was, okay, it's 2006 and now 2023, Netflix is huge, it's a mammoth. But I was looking at how many subscribers, so how much amount of data did they have in 2006, and they actually had 6.3 million subscribers. So it's not the scale that we have now. And the rates apparently for Netflix of the users are 2 million rates per day. So the users will give rating on movies about 2 million times per day. So just the scale of the data that Netflix had in 2006. So we're not talking broadband all over. We're not talking content all over. We're not talking apps on phones. We're not talking about tablets and mind boggling. And still, Netflix had enough data to ask for this type of a solution.
Indeed, indeed. Although, just a disclaimer, Netflix did not release their entire data set. So basically, they had released a sample of it, but still, that was quite significant, especially when we think about the computing resources that were available at that time. And in fact, there's yet another story also, right now we are focusing from algorithm perspective. So we are talking about this competition. But from business side, although there were people who could win this prize, there was an ensemble method, and a lot of advancement happened in the algorithmically. But at that point of time, Netflix did not choose to actually implement the winning entry at their production environment. But however, that is a totally different discussion. Again, we are
Mhm.
talking about 2006. Their business model changed, and all those things happened.
Mhm.
So,
Because
but it's
I wanted I jumped in just to give an image of the scale, because we were talking about a certain type of data in 2006, and definitely the Rexis competition that you organized dealt with data of 2023, which is light years away.
oh yeah,
2022 or whatever,
yeah,
it's light years away. I mean,
indeed,
we're discussing about different tools.
indeed, indeed. So let's move forward. Now we'll talk about basic approaches based on which typical recommender systems are built. Predominantly, you have content-based approach and collaborative filtering approach. And third one, of course, being the hybrid, where you bring element of both of them. So content-based approach. In this case, recommendations are made to a user by analyzing the description or the attributes of the item previously consumed by the same user, and also the description of the item to be recommended. Now, in this case, one very important point to be noted is only the data of that particular user is being processed to give recommendation. Now, as you see in this image, this gentleman, in the past, he purchased shirts which were dark in color and had collar. Now, among shirt 3 and shirt 4, if one of them is to be recommended, of course, we can know we should recommend shirt 4. Why? Because its attribute are somewhat similar to the shirts which this user has purchased earlier. This shirt 4, again, bit darker color, darker shade, and it has collar. So this is content based approach. If we talk about movie recommendation, then some of the attribute of movie can be the director, actor, genre, those, whether it is comedy or thriller, those kind of things. Those are the attributes which will be analyzed for a user's past history, and based on that recommendation will be made. So this is content based approach. And coming to collaborative filtering approach, before that I just want to talk about a very common sociology phenomena, something called homophily. Homophily, as the name itself suggests, homo and phily, love for same. It means birds of a feather flock together. Now, I'm sure in our real life also we would have seen it. Typically, we tend to be friends with people who are of somewhat similar kind to us. Yes or no? Rough rocks? Do you think it is true?
Uh, yes, but I also believe that we tend to um, embrace diversity as well.
Very good.
So we will come together on several important attributes, which usually talk about values and personal values, individual values, more than gender or nationality or color of the skin or whatever, or preferences. And in terms of recommender systems, if I am to think of it, and that's just shooting in the dark here, I assume that those values translate into our choices. So the recommender system will look at our choices and say, both of us have chosen something to do with business and something to do with technology, so maybe it should put us together.
Very correct. Very, very correct. In fact, the first part, I'm really glad that you could bring out the complexity of the real world. It is never as simple as this statement in the on the screen. Birds of a feather flock together. But the basic premise, something similar, it's attracted to another thing which is similar to it. This basic premise is translated mathematically into something we call as collaborative filtering approach. So collaborative filtering algorithm, basically it works on a basic, and again it's a very basic and very naive assumption, but still it is sufficient enough to make basic recommender system. And what this assumption is, if two individuals A and B like similar items or give similar rating to n items in the past, then they will do similarly for other item too. And it, at least mathematically, turned out to be a very successful approach. It is still being used a lot in the industry, and of course a very active topic of research in academia. To simplify this, I hope this image will help us in understanding it more clearly. As Professor Rox, you were mentioning earlier, these two people in the past, they had shown interest on something similar. For example, they both had ordered pizza, they both had ordered the shrimp shallot. Now, this looking can, uh, okay, I hope it's just a can of soda. So this can of soda, this person in blue jersey, blue cloth, he has consumed it. Now, since they both are similar in nature, at least mathematically, chances are this person in light blue on bicycle might also want to consume it, or at least might like it, might have a higher preference for it. Hence, this can of soda can be recommended to him. Okay, think one key aspect that I want to draw attention of everyone is, in collaborative filtering, we are analyzing not only data of one person, but of the entire users that are present in the system. Whereas, if you remember, In content based, we were analyzing data of only one person and her or his past behavior. Okay. Any questions or should we move ahead?
I think we can move ahead.
Okay.
What
So just
I took the time to link in the comments, and also to take the time to remind our audience to ask questions if they have any, is I've linked the an assessment from 2022 of Netflix optimal recommendation algorithm with
okay.
technical details, so it's a little bit more technical than the article on Spotify previously linked, but just so it's there as well. But
Okay.
so
Nice.
far, so good. Let's see.
Okay.
Collaborative filtering.
Yes. So let's see how a typical collaborative filtering works. And it's again a very simplified version of it because I just want our audience to get the big picture how it works. So typically collaborative filtering, it has 4 steps. One is user rating profiles, and then based on that, similarity is calculated. Once we have similar users, similarity score calculated, we create neighborhood for each user, and then recommendation is made. Let's see each of them step by step quickly. When we say user rating profile, this is a simplified version of it. Suppose if you have 5 users in the system and 5 items, so we can represent them mathematically in this matrix form, row and column. This matrix is typically called utility matrix. And over here, we have used 1 to 5 star rating system. So this number 3 over here indicates user 1 has given 3 star to item 1, user 1 has given 2 star to item 3. And this X you are seeing, it means user 1 has not previously consumed item 2, or user 2 has not previously consumed item 3, which you are seeing as X. So X means unrated item. Now you can also visualize this whole recommender system problem using collaborative filtering approach as a matrix filling problem. We have a matrix in which some values are filled and some values are not available, which you need to predict. And in fact, throughout its history, a lot of effort, especially during the initial days, was on looking at recommender system as a matrix filling problem. And all sort of mathematical jugglery was done to find best algorithm or best techniques that can make this prediction. So we talked about similarity. So typically a user similarity can be calculated, item similarity can be calculated. Now how it is calculated, we'll see how a typical cosine similarity, one of the most popular method for similarity calculation, is used. We should visualize each user in a vector space. Let us assume there are only 2 movies in the system. So on the x-axis, let us say we have movie 1. On y-axis, we have movie 2. And this is the rating: 1 star, 2 star, 3 star. Or similarly on the y, we have 1 star, 2 star. Now this over here, this tiger, let us say he has rated movie 1 with 2 star and movie 2 as 1 star. So he can be thought over here visually, and a vector can be imagined. Other, this panda, suppose he rated 1 star for movie 1 and 2 star for movie 2, which is on y-axis. So he can be imagined as this vector. Now if we take cosine of the angle between these two, we can consider it as a similarity. For example, if both were 100% similar, these vectors will overlap. It means angle between them will be 0. Cosine of 0 is 1, 100% similar. If they were opposite, then -1, or if it's perpendicular, then 0. So basically, cosine can be thought of as one of the proxy for measuring similarity. Similarly, we can have other similarity measure. Typical Euclidean distance can be calculated. Its reciprocal will be considered as similarity, and so on. And once we have calculated similarity, then we create neighborhood for each users. Then we simply use a weighted average formula to find the rating of a item or a content which user has not seen or used before. And if rating is higher, if the predicted rating is coming out to be 4 or 4.5, we will think that this user might like this, hence we will recommend it. This is the basic premise of typical collaborative filtering. Now, of course, there have been advanced method also. We use something called matrix factorization, SVD, and now we have a lot of deep learning-based, neural network-based methods. But basic premise remains same. Find similar users in the system, do all this mathematical jugglery, have this weighted average formula, and predict the rating. So I hope this collaborative filtering approach is clear. Now let's move ahead. Yeah, so as I was talking about, it was thought as a matrix filling problem. But one of the problem with this matrix is, especially when it comes to real world system, first is sparsity. As Dr. Rocks earlier were talking about, in Netflix, the size of data it has, millions of users, and hundreds and thousands of movies and series and all those things. In real world, most of them, a typical user might have seen, let's say, 1000 movie, 500 movie, or 200 movie. Most of the values will remain blank. So in a typical utility matrix, it might be like 99% all blank, which leads to something called as a sparsity problem. I hope it's clear, Dr. X. Sparsity problem.
Definitely. I was actually thinking about this sparsity problem because it's also a question of polarized data, right? For, let's say, Game of Thrones, you're gonna get a zillion ratings because you have a lot of people watching it. But for some obscure niche series, you're gonna get zero ratings and nobody has heard of it, and so on. So it's
Exactly.
a lack of data in some cells of the matrix, but also an inflation of data in other cells of the matrix.
Exactly. And that is very true. It happens in the real world system. There are some very popular products, popular content, as you mentioned about the series Game of Thrones. And since more people are watching it, more rating would be given to it, then chances are it might be even recommended to more people. And this will be kind of a circle that forms. And as we move forward, we will see how it can be broken, or at least some of the strategies
Mhm.
that are used
So
to
it's
break such
it's sort
cycles.
of like an echo chamber created.
Yeah, so we will talk about echo chamber, yeah,
Mhm.
and info. Okay. Another is something called cold start problem. Now, I'm sure all of you would have experienced whenever you get a new phone or new laptop where you have not signed in from your Gmail or Apple ID, then the kind of recommendation you see, for example, if you open YouTube on a new laptop, the recommendations will be totally bizarre. I mean, you'll be really surprised what kind of content YouTube is showing you. And one of the reason is because at this moment you are a totally new user to YouTube. So this is referred to as cold start problem. Basically, it happens when new user with no interaction history enters the system. Let us see how these things are solved. So in AI or in machine learning, there is a paradigm called transfer learning or TL. TL is basically a machine learning paradigm, and what it does, it makes use of knowledge learned in one task in a different but related source domain to solve a different task in the other target domain. So as you can see over here in this image, on the left side, we will see typical data related to recommender systems. You have users, you have product, you have rating. But there are a lot of auxiliary data also available nowadays. Your social network, the content we write, the mobile location and all. These things again, these data are highly available, and they can be also used to solve at least sparsity problem or cold start problem. And we'll see how. So basically this approach is called transfer learning approach, TL approach. So as you can see in this image, I have drawn a comparison. On the left side, you see the traditional approach, and on in which similarity was calculated just on the basis of the rating you gave. But on the right side, see, basically we are using your social media data. We're extracting that data, and when I say we, I mean in recommender system, this data can be also modeled. And that is used, for example, over here, we see your psychographic profile. They can be obtained, and based on that, similarity can be calculated, neighborhood formation is done, and recommendations are made. So some of the popular user modeling approach make use of five factor model, big five personality model. We might have studied in psychology. We have openness, conscientiousness, extraversion, agreeableness, neuroticism. Another model is very popular is basic human values. Basically, basic human values are desirable trans-situational goal varying in importance that serve as guiding principle in people life. So there are basic human values of a person which can be obtained, and people can similarity can be found on basis of the basic human values in marketing context, especially by the you might have heard about Maslow's need hierarchy. That concept was extended by Kotler and Ford, and they came with 12 user needs. Basically, these are something that a typical person hopes to fulfill when they are considering to purchase or consume a product or service. Some of such needs are a need for structure, a need for challenge, a need for curiosity, a need for harmony, and so on. So basically, a user can be modeled in a 12-dimensional vector space, and similarity can be calculated. Now, some of you might be having question, or people with some psychology background, you might be thinking, to get such data about a person, typically we have some kind of survey or form that need to be filled, which used to be the case, but nowadays, again, AI and NLP come to the rescue based on the text data. And in fact, now even by your observing your mobile, the way your finger moves on a mobile screen, your personality type can be identified. So I'll just show the sample data typically you find on a Amazon user data. So you have product ID, user ID, profile name, score you might have given 3 star, 4 star, timestamp, and the review text you have written, this piece of text. From this text, your basic human values can be obtained using natural language processing, modern algorithms. Your basic user needs can be identified. Your big five personality trait, their values can be identified. And once we can get that, then of course the similarity can be calculated based on those psychographic traits, and hence better quality recommendation can be made. I've also seen work which is being done on using MBTI profile. So all these MBTI surveys which earlier people used to fill, even those things can be obtained based on your text. Okay, uh, now we'll move forward. We have something called context-aware recommender system. I'm sure you'd have noticed the kind of content, for example, let's say YouTube itself, the kind of YouTube videos you watch when you're in office, and the kind of YouTube videos you watch when you're home alone in the night or with your family. The kind of YouTube content you're watching during weekdays, the kind of content you watch on weekend, typically they might be different. Let's come to song. The song you might be different at different weather's condition. You might be listening to different kind of song. Your mood again, maybe when you are happy, you are earlier Professor Roxana was talking about Spotify. They make heavy use of emotions. So we know that our preference for a song depends a lot on our emotion and our mood. So again, these things which I'm talking about, day of the week, location, your emotions, your mood, they all build what is called as context. And context is any information basically that is used to characterize the situation of entities. So now in recommender system also we have advanced access called context aware recommender system. And especially in marketing, at the organization digital marketing strategy can be further fine-tuned or can be further personalized, especially on the real-time context of the person. Depending on the location, for example, when you are at airport, you might be getting different kind of advertisement compared to when you are at a different place. So these all things are managed by something known as context-aware recommender systems. Another thing is something called cross-domain recommender system, CDRS. Now, inspiration for this comes from this idea. For example, if suppose I know you like the Harry Potter book, I have your preference for books, and you like the Harry Potter books, then should I recommend you Avenger Endgame movie? Chances are you might like it. So there can be dependencies or correlation between preference in different domain. And instead of treating each domain as independent, we can collect them and build something known as cross domain recommender system. It also helps solving cold start problem and sparsity problem. Although again, it might be seen as a threat, direct threat to privacy. You had given your preference for book. Maybe you might not have given a implicit or explicit consent to use it to get your preference for movies, but mathematically at least it can be done. This comes under category of cross domain recommender system. Now let's move forward. There are some special kind of users, especially in the context of collaborative filtering, that is of interest. One is gray ship user. I'm sure all of the you would have seen at least one black sheep in your family, or at least in case of mine, I myself is the black sheep of my family. Basically, there are users whose taste is very eccentric, and it is very difficult to make a prediction for them, even for us human. We all have this one friend who is very very moody. It's very difficult to guess what they might like or not like or those kind of things. Same happens over here. They partially agree or disagree with other users and have low correlation coefficient with almost all users. So the problem, and these users are called gray ship users. The problem of having such user in the system is, first of all, for a typical recommender system algorithm, it is very difficult to give good recommendation to such users, gray ship users. But the bigger problem is their presence in the system. What it does, it diminishes the quality of recommendation to other users also. So for the sake of simplicity, let us say if you have a user base of 1000 and only 10 users are gray ship user, so their presence, these 10 users, it will actually bring down the quality of recommendation to remaining 990 users also. Hence, these users' identification and removal from the system is something which can be looked upon. And again, just because your algorithm is failing to make good recommendation for these 10 users doesn't mean that they are not customers. They are also customers, they can be paying customers. So you might come with a different marketing strategy to cater to the need of these 10 users, or different recommendation strategy to cater to the need of these gray ship users.
Can't you? Sorry, question about this, because obviously, at least those that are not familiar with the systems think of Netflix or Spotify, right? So think of movies or music. So the question would be, I have these uncategorized and uncategorizable users. Can't you have a shortcut in which you recommend niche things, like the ones that don't have any views, or the ones that I mean, not necessarily personalized on their very heterogeneous experience, but just add to that heterogeneity?
So when you say uncategorizable users, are you referring to the cold start problem? People who are coming to the system for the first time?
No, I'm talking about the gray sheep ones that have very heterogeneous paths. So they have
Okay.
chosen, they have a portfolio of content that's very heterogeneous.
Mhm.
So instead of trying to find the red line in that heterogeneity, you're actually suggesting even more heterogeneity. So something
By
that's,
saying that, okay. So by I'm saying
by
implying that because
assuming
I'm saying that, yeah. Please continue.
the logic behind it would be, at least in my case, they can't fit in a box. So what we will continue to suggest them are diverse boxes, not the common path, so not the average, but very diverse and very extreme boxes, just to figure out more about them. That's why I said add to the heterogeneity, not
Okay.
try to make it homogeneous.
Got it. Got it.
Would
Yes.
that
Okay.
work technically?
Yes. So let me elaborate on that. So first, of course, I'm glad that you brought this box analogy. So these people are not fitting in this one box. So first of all, it is very important to identify these people and remove it from the present box. And reason for that is other people in that box, the first box, their recommendation quality was also declining due to presence of these users. So of course, these users need to be taken out of this box so that other users in this box, they at least get good recommendation. Now the second part, once we have taken these gray sheep users out of the box, we need to find a way to give them some reasonable recommendation. One thing which you are suggesting, go for some extreme ends, those kind of things, that can be done. Other thing which at least I'm sure of is done is content based. Maybe we can have a hybrid approach, because at this moment we are saying their taste is eccentric because they are not having good similarity quotient with other users in the system. But how about we analyze their own past history, and on that if we can get some pattern, and if we are able to get some pattern, maybe incorporate that also into the modeling part. That can be one. Other is, you also mentioned about finding extreme, maybe that can be also model. Some kind of hybrid approach can be tried. I hope it answers the question.
Yes, definitely,
Yeah.
definitely. I
And
mean, it was not a what can be. It was not a yes no question. It was more
in
like,
fact, when we,
investigating
yeah,
what could be done.
yeah. In fact, when we were working on Grayship users, I spent some of my time researching on Grayship users. And one of the approach we thought, is, at least from the marketing perspective, was should marketing manager also interfere in this? Maybe see these models and all in a typical commercial production environment, data science teams and all, they are working on it, and they are able to identify these Grayship users. But if you look at the bigger picture, maybe information about these users should be sent to the marketing specialist, marketing manager, or domain specialist, and maybe they might be able to come even with a better insight. They might do some manual intervention. They might have an interview with such users and all, and try to find some knowledge about them, which might be not getting captured in the existing data that is there. So even those interventions can be thought of. So okay, let's move ahead. Another very interesting kind of users is influential users. Now, when we talk about influential users over here, they're not your typical social media influencer or celebrity, but rather these influential users, sometimes they themselves might not be aware that they are influencer in a system. So in Rexis, in the context of Rexis, there might be a set of users who help a large number of other users to receive recommendation, because their taste pattern is such homogeneous with other users that their presence is actually helping other people receive good recommendation. So very opposite of gray sheep users. And these are not celebrity, or they themselves might not be aware. It's just that their taste pattern is in such a way that their presence is helping other people get good recommendation. So one thing it leads to, I'm sure all of you have heard something called algorithmic wars. Nowadays, algorithm of one company fighting with algorithm of other company. It's very popular in Wall Street, and when we talk about high frequency trading, algorithmic trading, and those things, something similar is happening over here. One of the is something known as shilling attack. In shilling attack, what can be done? One competitor can inject a fake profile in their competitor's user base by creating a fake profile and all, and somehow they can model that profile as an influential users, because that users is being used to give recommendation to a lot of other users. And once that fake profile has been established as an influential users, then whatever, like a funny thing you want to do, malicious thing you want to do, you can start doing that. So that is why their identification is very important to prevent shilling attack. And one thing that can be done, a very simple thing that can be done to prevent such thing is at least increase the cost of profile injection. For example, you can have captchas or verified user account, those things. So once you increase the cost of profile injection, at least some of the attacks can be saved or prevented. So we talked about influential users. Next, okay. Now let's move to the another part of this discussion. Till now, whatever we are talking about, predominantly we are focusing on how a recommender system works, especially how computer scientists have come with different ways to make them work. But as we move ahead, it is no longer just a computer science concept or a computer science problem that need to be solved, or typical matrix filling problem that is being solved or need to be solved, but rather it is gradually becoming a public policy problem. Let's see how. I'm sure in the past 1 decade, many of you have seen such things or people having belief in such things. There was a rise in such things in YouTube or in Facebook or in other social media. You saw a lot of communities getting established discussing on whether moon landing is fake or earth is still flat, or anti-vaccinators, or people believe in this cult and all, Illuminati, etc. What do you think had led to sudden rise in this, especially in the past 1.5 decade or 2 decade maybe? It's not like that these things did not existed earlier, but something happened which kind of gave rise, or which kind of brought these things back to at least some level of mainstream discussion. Another thing again, like when you talk about public policy and all, it was observed in one of the research, especially after this last US election, that YouTube recommendation were pushing more of election denial content to people who actually were believing, or people who were actually election deniers. So this was a proven research. Why it was happening? And of course, typically whenever I attend a conference or an event from public policy perspective or responsible AI perspective, typical recommender system is being presented as a villain for it. Like, like most of the problem are due to recommender system, which is in some way true. No doubt that recommender system have made life much easier. It takes away a lot of cognitive load from us when it comes to decision making, as Dr. Rox was mentioning earlier. In today's scenario, almost 80% of Netflix views comes from its recommender system. So people are consuming content 80% of time on what is being recommended to them, rather than them going or searching something over there. So Rexis no doubt reduces or lowers users' decision effort. However,
I have a
yeah,
question here.
yeah,
And
please.
this comes from having several streaming platforms, so not just Netflix, that are originating in different countries, such as IG, who's a Chinese platform, or Mubi, who's a niche platform, and so on. And all of them have some sort of a recommender system. You've mentioned that people prefer recommended or recommendations, recommended content versus them searching for it. However, in some platforms, searching for content is limited. Let me explain. Even in Netflix, you don't necessarily have lists of parameters that you can look for. Let's say that you are looking for Chinese war movies, right? You can't go through the search and input that and get just Chinese war movies. And you don't get all the Chinese war movies. So the search process, the search algorithm is affected. In some platforms, you, for instance, can click on an actor and go and look for other stuff that that actor has done, but not on all of them. In some platforms, you can look, let's say, for France in order to figure out more French movies, but you don't get French movies. You get movies that have France as either a title or the name of an actor. So, my question for you would be, you have here in the in the second spot the discouragement of exploration. uh it's not just discouraged, it's in some cases straight limited unless you know what to look for. So unless I know that I'm looking for that specific movie and I can input the title of the movie, just browsing and trying to figure out, okay, this one looks cool, I might click on it, it's quasi impossible in some platforms. So what's your take on that?
Okay, so that's a very good observation, Dr. Rox. Some case it can be by design. Maybe the designers of the system might have more benefit where they restrict these choices so they can push the content which perhaps might be making more money for them to these people, to the consumers. So that can be one thing which I can think at this moment. And some cases it might be a bit technically difficult also. Remember when we talked about the data which Netflix had, the huge amount of data. Now if we expect Netflix to have similar search capabilities in its data that we expect, that we are used to when we are doing a Google search or a YouTube search, then again it might be a bit technical difficult for Netflix to achieve that level of search efficiency. So I believe answers lie somewhere here. Sometimes it can be by design, or sometimes it's just some technical limitations. And answer
And
again,
because the platform is small and it doesn't have enough funds to create a proper browsing system.
that could be again. And
Mhm,
one more thing, I'm I want to point at this moment again. It came after you mentioned. Till now, we were discussing on only finding the predicted values. However, in recommender system domain, the way they are presented, it also has a huge impact. So when it comes to UI and UX of presenting or interacting with recommender system, that itself, we can maybe sometime have a session on that. If we are presenting in list, vertical list, horizontal list, if you're presenting only one big image, other in small, you must have seen in Netflix, they very often keep on changing their user interface. So user interface design has again a lot on impact on the way people consume these recommendations. And this again is not focused only on visible UI. When we talk about Spotify and all, which are consumed by our devices, maybe by like Alexa or Google Home, where we don't have a direct UI, in that case also the way results are being presented also have a huge impact on how people consume it. So yeah, uh, okay, going forward.
okay.
So, yeah, so so Rexis, no doubt, it kind of makes decision making quite easy for us, but it has a lot of drawback. We all are aware of by now this filter bubble problem and echo chambers, which Dr. Roxana mentioned earlier also. And in fact, this filter bubble, it's not this generic filter bubble, but now this misinformation filter bubble, which are basically states of intellectual isolation and false belief or manipulated perception of reality. They can be characterized by high homogeneity of recommender search, which basically share the same positive perception. For example, this example which I gave, election denial content. No, so of course, over here we cannot make a judgment whether it was a misinformation or correct information. But what it was found, that people who were already believing or who were already election deniers, they were being recommended more election denial content. So if it was a misinformation or other scenarios like this moon landing, and I do hope all the audience of this session, you do believe that we actually went to the moon or earth is fair, not a flat and all. But people who have some believe in this, they will be more shown, they will be shown more or recommended more of such content. So earlier we talked about filter bubble just, but now we also need to think in terms of misinformation filter bubble, which are becoming a more like a bigger malice.
Mhm.
So how, the
There
way,
was,
yeah.
and I'm gonna I'm going to add to this story a little bit because there is a very cool case study. And it's related to information regarding the vaccines during the pandemic. And that article, and if I'll find it, I'm going to link it in the chat as well. Um, says that most of the vaccine deniers came or at least sprung from an unexpected community, and that community was the community of self-conscious well-being supporters, like the ones that are promoting safe and clean eating, that are promoting not using a lot of detergent or a lot of processed substances and so on. And normally, that's well-being. I prefer wearing unprocessed fibers such as linen, so I'm gonna fall under the well-being thing. That is not a a trait that is to blame, if you wish. So well-being, obviously, all of us want it, right? So you have this community that's focused on well-being that apparently was very vulnerable to the idea of the messages that were promoting not using vaccines. And the way the recommender system worked was contextual, obviously, but it was also very much um perverted, if you wish, very
Yeah,
subtle. So it was not these people did not write or look for anything about vaccines. They just promoted the idea of well-being. So whomever introduced in the recommender system the idea that well-being means don't get a vaccine, that was the brilliant
yeah,
trigger to push to push the path forward. So just a little bit a tidbit of that information,
yeah.
because sometimes the misinformation and the manipulation does not come directly, so it's not
Indeed,
straightforward.
very correct. It's very subtle. Yeah, like it can be very subtle. Yeah.
Hmm.
Okay. In fact, one more thing. Quite often we use this term filter bubble. Over here I have also used, but there is another term echo chamber. So quite often they are used synonymously, but there is again a one subtle difference. Filter bubble, typically when we talk about filter bubble, we are talking about this modern digital online context, like people being recommended the product which they have earlier shown a preference for, which again narrows down their worldview. When we talk about echo chamber, they not only can be online in nature but also offline in nature. So echo chamber can be due to both offline and online component. So maybe in this case study which you're talking about, since you're talking about this community, there will be definitely some offline thing also, like their offline lifestyle and those things, which again might have led for this echo chamber. Okay, so let's again move forward quickly. So beyond a matrix filling problem, one of the reason why we are seeing all of these things happening is because focus has always been on, or traditionally, the focus had always been on predicting what user might like most, 4 star, 4.5 star rated content, and for which the algorithm accuracy matrices that were used were typical MAE RMSE. However, when we talk about responsible AI and all those things in context of recommender system, instead of focusing only on algorithmic accuracy, modern approach is also focusing on things like novelty. So remember earlier we talked about Game of Thrones being already quite popular, has a lot of rating. Chances are it might be most preferred for even those people who have not seen it. But if there are certain novel content for which still we don't have enough rating and all, but how about recommending such novel content? Focusing on novelty also, less popular items. Perhaps people might like it, at least give exposure to people to those things. Diversity, Let's say if I like action movies, and algorithm, if you focus only on the accuracy, algorithmic efficiency, typically most of the 4.5 star rated content or 5-star rated content will be in action movies for me. But what if the algorithm decides to give me a diverse content or maybe some tragedy or some romantic movie for which algorithm might have detected I might not give it a 4-star or 5-star, but still it is recommending me a diverse content. And if I like it, then again further things can be done. So now focus is moving toward novelty, diversity, transparency, and explainability. Especially explainability is quite important. If a recommendation is being made to me, then if it is also explained to me that why this recommendation, why this thing is being recommended to me, it will lead to two things. First of course, it is a responsible thing to do. And second, chances of me actually making a better decision to whether consume it or not consume it will be higher if explanation has been also given to me. So now we are focusing, this community is moving forward in this direction. Privacy concerns, again, it's something typical which we have with other AI things also nowadays. User information, unfortunately, has become a commodity. But at the same time, we also have a privacy paradox. Like typically, when you ask a person whether you value your privacy, yes. But when you see their actual action, sometimes they can be very casual about their privacy. For example, over here, we have quite observed in our student this dichotomy. At one side they will say yes, they are very conscious about their privacy, they value their privacy, their data should not be shared and all. But if we give them some, not me, but if some company, as part of their promotional policy or promotional campaign, if they give it, they give them some vouchers, gift voucher for $50 or $100 and ask it to share their contact list or forward it to 100 people in their friend circle and all, they'll easily do it. So this dichotomy between our actual actual action and what we think we view about our privacy, this is called privacy paradox. And privacy concerns are common in recommender system also. One thing which we talked earlier, your data has been collected for books, but if that data is being used for making recommendation for movies, is it legal or not legal? It's again not a black or white answer. Different part of the world, like in Europe and all, thankfully we have GDPR and all those rules. I remember when GDPR came, a lot of recommender system and data scientists, they had to do a lot of things to adjust their system and all. But gradually things are, like getting regulated over there. In other parts of the world, laws are yet to catch up to deal with these things. uh, Now we'll quickly talk about the way forward and end the session. So
one
typically,
one one comment on this,
yeah.
Abhi. And this stems because apparently our webinars have nothing in common amongst each other. Our previous webinar was with an anthropologist and we talked about AI and robots and so on. We totally recommend that conversation as well. In the context of the conversation with Alex Dinkovich, the anthropologist, we mentioned a philosopher. He's a German South Korean philosopher, Byung-Chul Han, and he has a very cool book. The benefit of his books are that are short and very well, you know, uh, concisely written. And he talks about the transparency society. How, on the one hand, we worry about our data and we care about our data, but on the other hand, we exhibit ourselves and we put in data about ourselves continuously. I mean, we show our homes, we show our libraries, we show our bookcases, we show our universities, our outfit of the day, our meals, and so on. Nobody asks for that. But we put in deliberately that type of content. And the thing is, that's we don't acknowledge the fact that that's data that can be used for our recommender system. I mean, not just words, not just, the way we walked around the city or so on and so forth, but just, content that we put up ourselves. There's a conversation right now on an article that I was reading, the fact that even our photos, the ones that we upload on Instagram or with our faces, the ones that we upload on Instagram or on Facebook or on whatever, are used to train image AI. And that's not something that you thought of when you're uploading a selfie on Instagram, right? So the privacy paradox that you were mentioning is actually a labyrinth of decisions that we need to take into consideration and so on.
Indeed, very correct. And so, just like you mentioned, images being trained to get information about your personality and age and gender and all. In this example, I have shown how text can be used to get your personality type and all. And it's getting even more subtle than that. Again, images and text is something which at least we can have some control. We can decide we won't upload our image, or we can decide we won't post any text and all. But now I'm sure all of us are using mobile phone. So the way we move our thumb, our fingers on mobile phone, sometimes very quickly, sometimes very slowly, in certain patterns and all, even they can be used. Even though you're not typing anything or uploading any information, but based on the way your hand is moving and those kind of signals, they can be used to identify your personality, your psychological trait. And once your psychological traits are identified, then you're totally helpless. Ads can be targeted, such content can be made, especially catered for your personality and those kind of things.
So
So that is why,
we're fighting naked in front of an enemy, quote unquote, that's also
unfortunately,
friendly with us, that we also
indeed,
like,
and
but that
yeah,
can, and we have no armor.
yeah. That's why I mentioned it's no longer a computer science problem, but it's a public policy problem. So I'm glad that economists like you and all those who are coming into this discussion, who are in the position to influence policy and all. And we'll quickly talk about this also and then close it. Just 1 minute. So Rex's community, the way forward. So whenever it come to any topic, especially where we have a lot of academic research and which is moving very forward, the way I look at, I try to see which are the important top conference in that domain, who are the kind of people who are sponsoring such conference, what kind of workshop and all are happening over there, because that gives a very good idea how things are moving forward in that particular topic. So in Rexis, there is a topmost conference called ACM Rexis Conference. Last year it was uh, held at Seattle. This year it will be at Singapore. It's a very vibrant, diverse, and welcoming community. And if you look at the sponsors for this conference, luckily we have all the big tech, even companies like BCG Gamma is sponsoring it. For me, it was a bit surprise why these, top consulting like BCG and all are into such conference. But I'm sure you yourself, being an economist, can think of the reason, because it is no longer something which is in the domain of computer science. Consultant, business houses, and all, they are over here. You mentioned of Spotify, Netflix, Microsoft, Google. Everyone is in this. Thankfully, it's a very open community. It's a very welcoming community and all. So that's at least good thing. Next of this conference is happening in Singapore in 2023. I just wanted to, the reason I mentioned this, because I wanted to show you the kind of workshop they're having. It will give you recommender system. Till now we are thinking of something monolithic, but now in different areas there are a specialized community who are working on recommender system, taking the field forward. For example, you will have a workshop on human resources, recommender system in human resources, music recommender, a special group for music recommendation, human decision making for recommender system, large scale video recommender system, workshop for evaluation. Then you have a workshop for responsible recommendation, fashion and retail, recommendation for behavioral change, recommender system in tourism, context aware, a different event for news recommender system. So now recommender system is no longer a monolithic. Each of the areas and all, they have picked up the clues and taking the field forward. A specialized recommender system for news are being made, for music are being made. Each domain has its own challenge, its own solution, and so on. Earlier we talked about Netflix prize and last year prize. So this year again the challenge is open. Luckily, I happened to be one of the co-organizer for this year also. And this time the challenge is being sponsored by Indian social media company. The data which has been shared is of basically it was from vernacular language social media platforms. That is Rexis Challenge 2023. It is still open. So those of you who are watching this webinar, in case and there is still time, 1 or 2 months are still there, so you can consider participating this. And for academic also we have a different prize. For regular team we have different prizes. And with this we come to end of my session. I started with a meme. I'm also ending with a meme. Some of you might have seen this documentary Social Dilemma on Netflix, and chances are Netflix own recommendation algorithm might have recommended you that documentary. So that was the irony. And yeah, so this is it from my side.
Uh, Thank you, thank you so much. I was still laughing at the meme. Uh, and I was actually wondering, if the recommender system itself has a sense of irony, and it's like us bashing ourselves in a self-deprecating way. They recommend uh, documentaries that challenge them or deny their importance.
It is. In fact, non-recommender system event. So like last week, I was an event at a very prominent institute over here, and it was on responsible AI. So we have public servant and social scientists, psychologists, and all for 4 days that workshop. And it was, the way it was being conducted, recommender system became the villain of that event. That all the problems that are due to modern AI is due to recommender system. So yeah, sometimes they are very creepy, but there is a certain element of irony in it also. But yeah.
True, but you see, one element that we keep on discussing, at least in risk management, is the fact that we have the tendency to have single perspectives on things, and single perspectives. All the damage done by AI is due to Rexis. Obviously not. Not just that. The fact that AI is hallucinating right now, and the fact that you know
Yeah.
it's if you ask, and it's quite famous, if you ask for a reference list from ChatGPT, you're gonna get a reference list, and then you start to look for those articles, and you find that they don't exist. ChatGPT just suggests title of articles that might fit into that, which is a good way to use ChatGPT, like
Indeed,
find
indeed.
me a proper title, but it's not a good way to look for a reference list. And that's the basic hallucination. It's not just that. The fact that there are black box elements in which we don't quite understand how things work. Thank you so much for shedding a little bit of light on recommender system and how we get that as users. But without this type of a conversation, we wouldn't know. I'm an economist. I look at Netflix's number of users, the fact that one of their key risks is to keep subscribers and to grow the subscriber base and so on. I don't look at the algorithm per se. I look how that algorithm translates into money. The same with Spotify. I look for the revenue system, and I look for the way they pay the artists. But again, this type of a conversation with a specialist such as you will shed light on a thing that for me is the black box. But in terms of AI, there are black boxes that not even specialists can explain.
Somehow,
And
yeah. I mean,
yeah, there's a very famous interview from, was it last week or something, with the CEO of Google, and he was the first one who mentioned it. But one one dilemma that I have is, we can't fully break free of this. It is bound to be the way of the world. I mean, when recommender systems are added to that layer of Internet of Things, like when your washing machine starts suggesting programs and duration and quantity of detergent to wash your clothes in, that's the path forward. So we can't really break free of this unless
oh
we go
yes,
off, but that's not the
exactly,
case.
exactly,
But
exactly.
what would you suggest we do? Like, be more aware of it, clean our browsing history periodically, keep some things offline. What would you suggest we do to still keep a little bit of, as much as we can, obviously, a little bit of a balance in this, and not be, completely naked and without an armor in front of the enemy?
Okay, so that's a very deep question. Actually, I wish I had a very simple answer to it, but there are few things that are being done not only from user side also, but by the company side itself. So thankfully, as I mentioned earlier, recommender system, thankfully, is no longer something that is only being controlled by computer scientists. Now we have people from different domain working on it. So you must have noticed that if, for example, YouTube, when we talk about responsible AI and responsible recommender system, you might have noticed that if you are watching YouTube continuously, it itself might give you a warning that you have been watching it since long time, maybe time to take a break. So when we talk about digital well-being, there are tools being built by the platform, these platforms themselves, and also something which you can install separately in your mobile phone. So I have a Motorola phone which again has a feature which kind of prevents me from continuously binge watching such content. So these things are happening. Another thing is, I remember there was a project, I'm not sure how far it has gone, but it was a recommender system for self actualization, and it was a NSF funded project where they were talking about again responsible recommendation. And even these companies, these algorithms, manufacturers of this algorithm, they know what you will like, but deliberately, being responsible member of society, they won't keep you continuously recommending those things which will you kind of trap you into that binge consumption pattern. So these are something that's happening. One thing for AI as a whole, which I suggest to everyone, to my student, to my clients, to everyone. Remember, today I started with that story from Buddha times, that you have a few blind men and something over there, elephant, trying to describe. So always, whenever you are looking at AI or any product, digital products which are, with advanced technologies and all, always remember that story. Chances are, what opinion we might have formed about that product, it would be very limited. So always keep on trying to expand your horizon, maybe attend such sessions, read books, participate in events which are outside your comfort zone, those kind of things. So keep your horizon expanding. Don't have a very rigid worldview or any particular strict view about any new technology or any new product. So this is
Mm-hmm.
what I could suggest. You know.
Thank you so much. While you were suggesting this, obviously, you've mentioned it, and it's one of the first things to do. Is what's in psychology called a nudge. A tiny
Mhm.
little change in your behavior in order to generate larger impact. And there is a very famous study done on smartphone usage and how to use nudges for that. And the nudge that you can actually use on any type of smartphone right now to reduce consumption of apps and mindful scrolling and so on and so forth is actually to turn your phone to on Samsung, for instance, on grayscale, on sleep mode. But grayscale overall, I mean, even if you don't have the sleep mode right now, you can change the screen to grayscale, to black and white, and that will actually reduce the attraction that we have to mindless scrolling. You're going to find yourself in all the photos on Instagram are black and white. They're not as cool. And as a wrap up, I would suggest a website that's called Healthy Screens that also suggests strategies to use. But you can take 3 minutes there and check your smartphone addiction,
Yeah.
and see if you are addicted to your smartphone or not. I think I can honestly say that I am, even without the test. But you also get strategies from it. They are academic based, so it's a project
Indeed.
that has generated
Yeah.
that. And
Yeah.
I just wanted to bring this into the conversation as well, because the less data we provide to be profiled on, the less profiled we are, so to speak.
Indeed, yeah. And
Uh,
one more thing, Rox. Again,
mhm,
continuing the answer to your question, sometimes there are deliberate policy level intervention also by different governments that are required. So I'll give you an example. Again, different countries have their own set of governments and all. So in India, TikTok is totally banned. I know in Europe and North America, TikTok is a big source of concern for many people, especially
mhm,
seeing the young people getting addicted. In India, TikTok is totally banned. Other thing is in China itself, I'm not very sure, but I think I have read somewhere TikTok for young people is banned after a certain time in the night, maybe after 8 p.m. or 9 p.m. So sometimes even these harsh policy level intervention by governments are also required. You know, as I mentioned earlier, recommender systems are too important now, or AI in general, too important for it left to be only to tech companies or to computer scientists. So
mhm.
that is one more addition. Yeah,
Obviously, that's why one of the reasons why in this project, I mean, we're not looking just as digital transformation. We're not looking just at intelligent automation or just at um, um, artificial intelligence. We're also looking at algorithmic governance, and algorithmic governance in its two understanding of the word. First of all, governance of algorithms, and then governance by algorithms. So
indeed.
that's an interesting point. You've put it quite correctly a little bit earlier that um, you can um, look at the issue not just as a business issue, just not just as an individual issue, but more of a public policy issue. I was looking at the limitations for TikTok in China. Actually, children in China are limited to 40 minutes per day on the app.
Yeah.
So it's a duration thing.
So
It's not a timeline. They can use it at night, but
could be, yeah,
they are limited at 40 minutes.
could be, yeah.
Uh, which could be, I mean, looking at the European kids using TikTok just 40 minutes per day, that's kind of complicated.
I know, yeah.
uh, but I mean, obviously we would have hours to discuss on the topic.
Indeed.
Thank you so much for taking the time. I see that we don't have any questions right now in the chat. What I would suggest is, if our audience has questions after the live stream, you can still find us. I mean, we have linked the Raxis challenge, and they have your contact details there. They have the details of the project, and we'll get back to them. Thank you so much, Abhi, for again taking the time and explaining so comprehensively and so clearly what these things are about.
Thank you very much, Ross. Thanks for having me.
See you,
It was
see
indeed a
you,
pleasure.
see you soon in some new projects.
Indeed. See you.
All the
Okay.
best.